Alright, in this part of the class, I will be dealing with angles too. Second part of angles. In the first part, just a recap, we dealt with Pythagoras theorems, SOHCAHTOA, where we talked about some major trigonometric ratios like sine theta, cos theta, and tan theta, etc. So here I'll be talking about acute angles to start with. Acute angles. Then I will also talk about right angles. Right angles. Then we'll look at straight angles. Okay, let's say obtuse first. Obtuse angles. Then after that, we'll consider straight angles. That's angles on a straight line. Straight angles. Number 5, I will talk about let's call them reflex angles. Reflex angles. And then we'll continue with what is it called again? Angles at a point. Angles at a point. At a point. Alright? Okay, perfect. Right, to start with, an acute angle is an angle that is less than 90 degrees. So an angle of 20 degrees is an acute angle, 40 degrees is an acute angle, 45 degrees is an acute angle. So long as less than 90 degrees, we call it acute angle. That's about acute angles. Example of an acute angle is something like this, where here is maybe 30 degrees. That's an acute angle. Then the second one is right angles. What is a right angle? A right angle is an angle of 90 degrees. Angle 90 degrees drawn as this. This symbol is symbol for right angle, 90 degrees. You can see this in places like, let's say you have a scalene triangle like this, and you have something like this at the point here. This signifies right angle, which is equal to 90 degrees. That is this. Then for the number 3, obtuse angles. Obtuse angle is an angle that is greater than 90 but less than 180. For example, normally on a straight line like this, acute will be like this, less than 90. Then right angle will be like this, 90 degrees. But then since obtuse is bigger than 90 but less than 180, that means bigger than 90 should be like this. And this could be maybe 110. After all, 110 is bigger than what? 90. And it continues in that order. Then we have straight angles, which is also called angles on a straight line. Angles on a straight line looks like this. These are angles that sum up to 180 degrees. For example, you can have something here, you can have another angle here. At the end of the day, if you sum A, B, C together, it will give you what? 180 degrees. So straight angles or straight line angles or angles on a straight line are angles that sum up to 180 degrees on a straight line. Then we have reflex angles. Reflex angles are angles that are bigger than 90 degrees but less than 360. They are bigger than 180 degrees, but less than 360 degrees. Don't forget, reflex angles are angles that are bigger than 180 but less than 360 degrees. Sometimes we can denote them like this, where this is an angle, maybe you say 270 degrees angle depending. Then angles at a point. Angles at a point, these are angles that are equal to 360 degrees. Equal to 360 degrees. The situation whereby you have something like this, and all of them, okay, we've used ABC before. Let's use X, Y, Z. At X, Y, Z is summing up to 360 degrees. 360 degrees. Two parallel lines, say AB and CD. If AB and CD are parallel lines, please follow closely, such that there is a transversal cutting across the two of them. Now, there are some angles that are formed when a transversal cuts across two parallel lines. This is very, very important for your exams, so pay close attention. One of them is the one we call corresponding angles. Corresponding angles. The number two is called alternate angles. The third one is called opposite angle. Sorry? Opposite angles. Now, let's label it. Given that here is A degrees, this other side is B degrees, and we have our C degree here, and then this is D in degrees. We have E in degrees, F in degrees, G in degrees, and then we have J. Okay, let's have H here in degrees. What this, before we continue, I must tell you that corresponding angles in a situation like this are equal. Alternate angles in a diagram like this are equal, as well as opposite angles. Opposite angles are also equal. So that's to say, okay, first of all, let us identify the corresponding angles here. The corresponding angles here are B and F. So B, under corresponding angles, B is equal to F, meaning that whatever value that B takes, that's what F will take. If the value of B is 20 degrees, then F should be 20 degrees as well. Another example here is this, D and H facing downwards together. It also means that D degrees is equal to what? H degrees. There are corresponding angles. We also have them here. A degrees is corresponding to E degrees, etc. There are still many others here if you check. Then to alternate angles. Alternate angles are angles that are facing slightly opposite to each other, like C and F are alternate angles. They are alternate. Something like this. Something like this. Look at this. We have another angle here. Let's say this is X and then this is Y. X is equal to Y. Why? Because they are alternate angles. And alternate angles are what? Equal. So if here is 45 degrees, then Y should also be what? 45 degrees. So alternate angles here are C and F, D and E, etc. Now we have opposite angles. Let's wipe this. Opposite angles. Opposite angles are angles that are facing opposite to each other. For example, A is opposite to D. So angle A is equal to angle D degrees because they are opposite angles. Then angle B degrees is also equal to angle C degrees because these are opposite angles. Angle E degrees is also equal to angle H degrees. They are opposite angles. Then F degree is equal to G degrees because they are opposite angles. This is supposed to be F. Alright, now we have a couple of examples to solve on the board. The first one says, in this figure, where we have angles at a point, first side is 4x, second side is 5x, and we have 3x here. Find the value of x, find x. Second question, in this angle here, this diagram on the board, where we have 2x minus 9 as the first angle and 6x minus 11 as the second angle, find the value of x. Then we have this last one, where we are asked to find y. We have two variables. We have two variables here, x and y, but we are only asked to find y. Alright? Now, looking at this and considering, making reference to the examples and definitions I've given previously, you will come to conclusion that this is nothing. It's very simple. It's what you can do. Alright? Looking at this is coming from angles at a point. This one is coming from angles on a straight line, and this is coming from corresponding opposite and alternate angles. So let's get to it. The first one first. What do? Already we know that angles at a point sum up to 360. So what do we do now? Simple. Let's add them together. So the first one first, we'll be having 4x plus 5x plus 3x should be equal to what? 360 degrees. Now, if we add this together, we'll be having 9x. 9x plus 3x is 12x. Being equal to what? 360 degrees. What else do we do? From simple equation, you have to divide both sides by 12. And when this cancels out, x will be equal to what? Pause the video and check. Pause the video, check. If your answer is 30, then you are very correct. That's the value of x in the first question. Then the second question, this is very simple as well. Since we already know that angles on a straight line sum up to 180, that is to say they are supplementary, we just have to sum everything together and equate it to 180. Let's get to work. So this is going to be 2x minus 9 plus everything here, 6x minus 11 equal to 180 degrees. Is equal to 180 degrees. So let's add together. 2x plus 6x is 8x. Minus 9 minus 11 should be giving us minus 20. Or equal to what? 180 degrees. Now this will come over to the right hand side, right? So I will be having 8x to be equal to 180 plus 20, which then means that 8x it's equal to 200. So as usual, divide both sides by 8. Don't forget this is 8. And 8 will cancel out. So therefore, x will be equal to what? Pause your video and check again. You should be getting 25. 25 should be your answer. Then the last question. Here, the third one. And it's still simple. But then in mathematics, we always use what we have to get what we want. Use the given parameters to get whatever it is you're looking for. We were asked to get the value for y. But then from angles on a straight line, we know that if here is 135, what should be x such that if we add them together to give us 180? What's our calculator and check. We should be having 45 here. So if x is actually equal to 45 degrees, then we are done. How? Simple. We are looking for y. But then remember that y and x are alternate angles. And I told you that alternate angles are equal. That means x is whatever y is going to be, and y will take the value of whatever x is going to be. So since x is 45, therefore y is also 45 degrees. Thank you for watching.